Hi guys, welcome to Math Jamaica. Okay, so today we're going to talk about functions. Yay! Alright, now in this problem we're asked to find the domain of f of x is equal to the square root of x minus 1. Now what exactly is a domain? Well, a domain is really the x value, like what value of x satisfies the equation. So in this case, the domain would be x, the range or the y value would be f of x. Now in a case like this, well, not in a case like this, normally the domain for an equation would be all real values. What are real values? Pretty much numbers, regular numbers. 1, 2, 3, -5, all numbers. But in this case, it's special. Now, if we plug any and any number into x, we might not be able to satisfy this equation. So what value for x would cause a problem here? Now, if we had substituted, say, for example, x is equal to 0 into this equation, we would get -1. And we all know that we can't find the square root of a negative number. We can't find the square root of a negative number. Let's just roll with that for now. So we know that we would not be able to satisfy this equation. So any value below 0 would not satisfy this equation because all numbers below 0 would give this a negative value, and we can't find the square root of a negative value. So in order for us to satisfy this equation, let's try x is equal to 1. Now if we substitute x equal to 1 into this equation, we will get 0. And we can find the square root of 0. That won't cause not the computer, but the calculator to explode. So therefore, we can estimate from that the domain for this equation in particular is x is greater than or equal to 0. So pretty much once x is no, not 0, 1. So once x is greater than 1, it will satisfy this equation. If we put x equal to 2, 2 minus 1 gives us 1, the square root of 1 is 1, etc. So I hope you understand that one. Stay tuned for the next. Okay, so the next question we have is g of x is equal to x squared plus 1. Now, in this case, there's nothing fancy, there's no square root, there's nothing, no fraction or anything. So in this case, the domain would actually be all real numbers. So any number you use for x would be able to satisfy the equation. There'll be no problem. So if we want x is equal to 0, 0 squared equal to 0 plus 1, g of x would be equal to 1, no problem. If we want to use -100, example, x is equal to -100, then 100 squared would give us
10,000.
Right? 10,000 plus 1 gives us.
If you're going to ask for it, I swear to God.
So any number that we use for x will satisfy the equation. And therefore, the domain for this particular equation would be all real numbers. Okay, so here we have h of x is equal to 3 over x minus 3. So just like the first one, we can't really have all real numbers because there's a fraction here. So we realize that in the denominator we have x minus 3. Now for here, not every number can satisfy x. Well, actually, it's only one number in particular that won't be able to satisfy x. As you can see here, if x is equal to, for example, 3, then this would be equal, the bottom equation would be equal to 0 because 3 minus 3 is 0, which would leave the equation being 3 divided by 0. And we know that if any number divided by 0 is undefined. It's not 0. Remember, any number divided by 0 is not 0, it is undefined. So for this particular equation, x can be equal to any number as long as it's not 3. Once a number is equal to 3, it will render the equation undefined. So x in this case has to be greater than 3 or less than 3, but it cannot be equal to 3. Okay, and we're back again with functions. So this time we have, f of g of x. So when you see weird things like this, don't be alarmed. So up here we have f of x is equal to the square root of x minus 1. G of x is equal to x squared plus 1. And h of x is equal to 3 divided by x minus 3. So when you see things like this, you just stick one equation into the other equation. You stick the end equation into the front equation. So we're going to stick g of x into f of x and then solve. So we have g of x up here, which is x squared plus 1. And wherever we see x, we're going to put it into f of x. So what we're left with is x squared plus 1, because we're sticking wherever we see that into the x, and put by the minus 1. So x squared plus 1 minus 1, and we know that 1 minus 1 gives us 0. So what we're left with here is, I hope you can see it, x squared. And when we find the square root of x squared, we are left with, let me put it over here, the square root of x squared, we are left with x. If you can't see it, I'll put it somewhere else later. Okay, so in this case we have g of f of x. So like before, just going to stick one into the other one. So this time we're going to stick f of x into g of x. So take f of x, and wherever we see an x value, we plug it into g of x. So f of x is equal to x minus the square root of x minus 1. So we're going to stick that into where we see x into the g of x equation. So what we get is square minus 1. Please remember that in this equation, the square root is all over x minus 1 and not just x. Now, since in g of x, the x was squared, we have to put it back. Plus 1. And we all know that square roots and squares are enemies, so when you square a square root, it cancels through magic. I'm not kidding, I'm joking, it's not magic. Just wonderful math. So the square cancels the square root, so we're left with x minus 1 plus 1. And minus 1 plus 1 is 0. So we are left with x. So g of f of x is equal to x. Just like before, f of g of x was equal to x, but that doesn't always work all the time where you turn them around and you get the same answer. So, okay, final function, sorry, we have h g of x. So like before, what we're going to do, my brother's on his phone, what we're going to do is stick g of x into h. So obviously wherever we see x, we're going to put x squared plus 1. So 3, and we got x squared plus 1, because x, we put back the minus 3. So we just simplify x squared plus 1 minus 3, and that leaves us with 3 divided by x squared. Positive 1 minus 3 gives us negative 2. Problem solved. If you can't see it, I will, sort you all out.